For this bell work, we're going to solve for x, and we should notice, just based on what we learned from the last unit, that this angle, x plus 16, and this angle, 4x minus 5, are vertical because they are through the vertex, which means that we can set this up with the two angles, x plus 16, and also 4x minus 5. And since they're vertical, they are automatically congruent, which means they're the same. I can set these two equal to each other and then just solve this equation for x. So I will. With some principles of equality, I guess I'll get rid of the x first. I'll move it over to the right side, or zero it out at least, by subtracting x. And some of you may benefit from seeing that as 1x, because that's a 1x there, phantom 1x. But if I do it to one side, I got to do the other side. Okay, so that's going to zero that out, which allows me then to drop the 16. But now 16 equals 4x minus 1x. That'd give me 3 x's. And then I can drop this negative 5. Okay, but the last thing I'm going to do here, or the next thing I'm going to do, is get rid of that minus 5, because I just want the 3 x's by themselves. So to do that, I'll zero that out as well by adding 5. Just if I do it to one side, I'm going to have to do it the other side as well. So then I got 16 plus 5, which is 21. I can drop my 3x. And we zeroed out the minus 5. So now the 3 x's are isolated, which was the whole point there. But the last thing I'm going to do here is to make the coefficient of x a phantom 1. So how do you change a 3 coefficient to a 1? Just divide it by itself. But again, since I divided by 3 on the right side, I'll have to divide by 3 on the left side as well. 21 divided by 3 is 7. Here, now I'll just make this coefficient of x a phantom 1. And then I got 7 equals x. Now, if I've done this right, which I think I have, but I can check. I can go to the angle on the left there, x plus 16. And I can say, well, what do I get if I replace the x with the value that we found, which was 7 right there? Well, then I'd have 7 plus 16, which is 23, which means that this angle right here would be 23 degrees. Now, if we've done this correct, it means I can do the same thing to the angle on the right, 4x minus 5, the vertical angle there. But if I replace the x with 7 again, I should get 23. So you can put this in the calculator, and if you do, you will. Again, just put this whole thing into the calculator, you'll get 23 degrees. And that's what we were expecting, because the angles were vertical, they're supposed to be congruent, or the same, and we can see by replacing the x with 7 here and here, that they actually are the same. So this proves that x equals 7 is actually the solution to this scenario here. And here's our objective for the day. The first objective for this unit, I can identify translated figures and translate figures. So take 15 seconds and copy that down, please. So just to start off here, we got a little bit of vocabulary that we need to go over. Got pre-image and image. So we're going to be looking at figures, okay? Usually rectangles, quadrilaterals of some type, maybe triangles or pentagons. It doesn't really matter, of some sort, okay? So some kind of closed figures that we're going to be looking at, and we're going to be changing them just a little bit. Sometimes we're just moving them, sometimes we're kind of flipping them over or rotating them to some degree. We're going to be doing that kind of stuff, okay? But the image is the figure before anything has happened to it. So it's what you start with, okay? So let's say here the pre-image is what you start with. And then the image of that is the figure after whatever you've done to it has happened. So today we're just looking at for this lesson, we're just looking at moving them. But again, this is the image is the figure, is kind of what you end with. That's one way to say it there. But again, it's after you've done something to whatever figure you're looking at. Now, we'll indicate that an image is an image, usually with these marks. Sometimes we won't, but sometimes we will. And it is possible, by the way, to do this with just points even, right? So you could say, well, hey, look at this point right here. Let's call it point A. If I were to, let's say I move this to the right and maybe up just a little bit, and now I have this new point right here. Generally speaking, we'll call it A prime, but we don't have to, okay? And that's what this mark is right here. It's called a prime mark. And that's how this, what I've written there in purple, it'd be considered A prime. All right, and again, the prime mark is just that it's telling us that we've taken an original point right here and then we've moved it, maybe to the right and up. Sometimes you move it up and to the left. It doesn't really matter as long as it's been moved. Then some kind of transformation has happened to this point. That may not make a lot of sense right now, but hopefully with some examples that we'll see today, hopefully that'll make a little bit more sense. So, translations. This is a type of transformation, but this is when we just move things, just like I did with that point A. But again, we're going to be looking at this with figures, sometimes points, sometimes just an object, doesn't really matter. But when we translate things, generally speaking, we're not looking at rotating things, flipping, shrinking, or enlarging. Okay, so whatever you have is just going to remain the same size. So I could start with some kind of trapezoid like this. And what I can do, especially with some technology, is I can say, look, my trapezoid, well, I can move it down and then to the left. See this? But notice, by doing this, because I'm just using technology, I just copied and pasted it, it did not change the size. That's the shrinking and enlarging stuff. I didn't really flip it around. I didn't rotate it. All I did is move it down and to the left, okay? Now, you may hear this word on the assignment that says map. It just means that you're going to move it. That's it. So moving things, another way to say that, because you will see this on the assignment, it'll say mapping. So I'll say mapping things too. But again, just here at the bottom, translations do not change the size of whatever thing it is that you're looking at. And just to emphasize that, you could do it with a triangle. Right, you can take this triangle. Let's see if I can copy and paste that. There we go. So if I took this triangle, I could move it maybe up and to the right. Doesn't matter. Maybe I just move it just a little bit up and to the right, something like this. But as long as it's been moved, we call it a translation. So translations on graphs is the way this is kind of going to work on the assignment. Just identify some corresponding points. Okay, so if you had, like we had in that last example, let's say we had a bit of a triangle here, and maybe it's even just been moved kind of to the right here. Okay, by identifying corresponding points, I'm saying, look, if I call this point A again, then its corresponding point right here, you could label it A prime like this. Sometimes they'll even just use a different letter. So maybe they'd even use letter D, okay? Now, if this happens where they're not using a prime mark with D, they may have to say this first triangle here would be your pre-image. And then the second triangle, they'll have to tell you that it's the image or that it's been moved or translated or transformed in some way. They'll have to clarify that if they're not using prime marks to indicate which one is the pre-image or the image. And that way you'll know which one you start with, because the first triangle was the one we started with, the second one is the one we end with. That's why this is the pre-image, that's why this one is the image. But again, you have to identify corresponding points. So the top is the top, this bottom left point is the bottom left point, bottom right is the bottom right. Because then, once you know that, and you know which one's the pre-image and the image, that's kind of part 2 right here, then you can figure out how far, for example, on this one to the right, you've moved it, maybe up or down as well. But once you know this, then you can, and that's all we're going to be doing on the assignment for most of them, is just saying it's been moved to the right 5 units. But the graph will indicate how far it's been moved. So this down here is kind of what it looks like on the assignment, in addition to this one, but the graph that you'll see right here. Notice on this one, they're not giving us or they're not giving, we can figure out the coordinates of the points, but they're not labeling the points. Like I said on that last one, like this one could be A and this one could be D, right? Doesn't really matter. But what they are saying is that determine which translations would map. So this is moving. We're going to move figure H onto figure I. So figure H, we're moving figure H, which means that's our starting figure, which also indicates that that is our preimage. Okay, we're going to move figure H onto figure I, so that's the figure that we're going to end with. But again, that indicates that we are looking at the image. Okay, so I'll go in here just to make sure that we have this clarified. And I'll say, look at figure H, this is our preimage. And then figure I is our image. It's what happens after we've done something to the preimage. By the way, why do they use that terminology? I don't know. I didn't make it up, but someone else did. And someone thought it was super awesome, which is why apparently you guys have to learn it. But ask your parents how often they use this in their lives. So, now that we know that, it says a translation blank, so we can see if you pull this down, it'll say left or right, this many units, and then it wants up or down, this many units. So we're looking at horizontal movement first. And then we will look at the vertical movement. Now you can look at the whole image, and image and preimage. But really, I like to focus on just one point because what we know, even if you've just had just a tiny bit of experience with computers and moving windows even, is that notice the sizes of these two figures doesn't change, right? So we're not really concerned about that right now. We will later. But it's just taking, really just, you could just look at one point at a time and then see how far those have been moved. So I'm going to focus on one point. The other points, really, I don't give a crap about. I don't give a crap because every point is going to move the same exact way, all right? So I guess I'm going to choose this top one right here. Okay, now I don't have to label it even. So I need to figure out what other point it corresponds with. Well, from what I can tell, it's this top point right here, right? You see it kind of comes to this peak right here. Some of you may have chosen this point as well, and I'll even show you that would work, and then you could have used these 2 points, but they're kind of close together, which is why I'm not using them. Okay, so what would I have to do on the grid? And this is pretty much like starting at this intersection and then driving down these streets to get to this other intersection. But we see here in the bottom left that it has to be a horizontal movement first. Okay, so that means I'd have to go to the left here. And then from there, I'd get to this street, I guess you can call it 3rd Street, but then I'd have to go down. So already I can see that I'd have to go, it's a translation to the left, it's a movement to the left, and then it would be a movement down. Now to fill in these boxes, I got to figure out how far they've been moved to the left and down. So I'd say, starting from this red point there, I'd move 1, 2, 3 boxes to the left. So I can put a 3 in there. So I've translated this to the left 3 units. And then how far down? Well, again, I'm just counting boxes. 1, 2, 3, 4 boxes. So I went, it's a translation, left 3 units and down 4 units. And that's all you got to do for these. You don't actually have to move the image or pre-image onto the image. You don't have to do anything like that, at least so far. All you got to do is say it's been moved left so many units or right, and then up or down so many units. That's it. Now, like I said, told you I'd do this with another point just to show you that it doesn't matter which point you choose, because it's possible some of you may have chosen this point over here on the left, which I'm using orange. Okay, so again, how far to the left is this? Because it is left first. Well, again, you can count the boxes. 1, 2, 3, 3 boxes. So I went left 3 boxes, and then you'd have to go down because it corresponds with this left edge, this left corner of this quadrilateral. But again, you've gone down 1, 2, 3, 4. So it's still left 3, down 4, and once again, it doesn't matter which point you use. You could have used this one, left 3, down 4, or you could have used this one right here, left 3, down 4 as well. It's always left 3, down 4 for this particular translation. So we see this one sets up the same, but you can look at corresponding points where you can figure out which one is the image and pre-image. Okay, but what I can see is that it says determine which translations would map, again, that's moving, figure U. So this means figure U, that's what we're starting with. This is our pre-image. Onto figure V, which means that that's the figure we get after the movement has taken place. So this is our image. So like I did on that last problem, all I got to do is find one point that corresponds with another point between these two. But again, I'll identify this on the graph as well. Figure U, this is my pre-image. And then figure V is the image. Okay, so that's what we get after the movement. Well, what do I get from this? You know what, I'll use the bottom point. Again, does it really matter which one you use? It does not. It does not matter. Okay, so I'm using this bottom point right here. Now on the homework, on the assignment, it's going to ask horizontal movement first and then vertical. So I'm going to go horizontally first, and here I can see that I'm going to have to go to the left first, and then I'm going to go up. Now you could choose those in the boxes right now, but I'm going to count the boxes as well so I know which is which. Okay, so to the left, I've gone to the left 1, 2, 3, 4, looks like 5 boxes. So it's left 5. And then you'd have to go up 1, 2, 3 boxes. So it's left 5, up 3. All right, fair enough. Let's go and fill those in then. So I went to the left 5 units. And then I went up 3 units. Done. For this one, it says determine which translations would map figure C onto figure D. Now this is important because it tells us, it says would map figure C onto figure D, which tells us figure C here is what we would call the pre-image. Okay, it's the figure before it has been moved or translated, which means that figure D would be the image. So just going back to what we talked about on that slide defining these, the pre-image is before it's been moved, the image is after it's been moved in this case. So what do we got on this one? Figure C has 5 points, figure D has 5 points, right? And we can see that the orientation hasn't been changed, which means they pretty much just taken this figure and then they moved it, I would say, to the right and up. See what I'm saying? So it doesn't change the size, it doesn't change the orientation, it's still oriented the same way. Everything's still the same on this, okay? So on the assignment, you're going to see boxes like this. A translation, it's going to go left or right, this many units, and then up or down this many units. So that's why I'm focusing on horizontal first and then vertical second. So let's choose a point here, and it doesn't really matter which point we choose. I usually start with one of the extremes, up or down, or even left and right. I'm going to start with the uppermost point, this one right here. Right now, it's not labeled. It doesn't have to be. I just know that this point comes from the pre-image. And if I looked at this other shape right here, I need to know which point corresponds to it. And of course, since I'm focusing on the uppermost point, it's this one here. So I've got to figure out how far this has been moved. It's been moved to the right, and then it's been moved up. And the grid lines are pretty much like streets that you drive on. You gotta stay on each street until you get to the other street you need to move up and down on, and then that'll take you to what would be your final destination here. All right, well, let's see kind of how this is going to work, and it kind of works the same way that slope would. So I'd say, I can see I'm going to go to the right here, and then from there I'd have to go up. So I'm moving to the right, and then I'm going to go up. I just got to, now that I know how far to the right and up I'm going, I just got to figure out how far. So I'm going to count boxes. So the red one, 1, 2, 3, 4, 5, 6, 7, 8. So it went to the right 8 units. And then it went up 1, 2, 3 boxes. So it went up 3. Now, if this has been translated correctly, each of the points should have been translated exactly the same way. And I'm not going to do it for all 5 points. But we see this one point. I can see that I can do it with any other point. So I'm just going to go to the other extreme. I'll go to the bottom here. Okay, so that's from the pre-image figure C. Let's look at the figure D, the image. And again, I'm looking at the bottommost point right here. Okay, has it also been moved 8 to the right and 3 up? Well, I can see it would be something like this, to the right and then up. So that's good. It is going to go to the right. And it is going to go up. But again, how far to the right and then up? Well, I can count boxes. 1, 2, 3, 4, 5, 6, 7, 8. So it did go to the right 8. It matches. And then how far up? 1, 2, 3. Okay, so to the right 8 and then up 3 tells me that we've done this correct. So on the assignment, you have to choose in this box right. It's gone to the right. How far? 8 units. And then up or down, well, we know this one went up. And how many units did it go? 3. And the truth is, if you did this with any other points on this, so I guess I'll use this one, you would see that this point as well goes 8 to the right and then 3 up to arrive at its corresponding point. And in fact, as I said before, you could have done this with all 5 of the points if you wanted to. So this point as well, 8 to the right, 3 up. Or this one, 8 to the right, 3 up. So that is a translation right there. And as long as you can see that each of these points is going either right or left, and then up or down, the same exact movement, then we know we are dealing with a translation. So we'll do the same thing on this one, and you can see, just like you'll see on the assignment, you're just choosing left or right, so many units, and then either up or down this many units, however many units. Right? So let's read this. Determine which translations would match figure M onto figure N. So figure M is the figure we start with, that is the pre-image. And then figure N is the figure we end with, which has to be the image. Pre-image and image. All right. So let's choose points. And like I said, I just like to start with the topmost point generally. Do you have to? No. Some students may start with any one of these other 3 points and use those. I like the topmost point just because, I don't know, it just works for me. And I can see that it corresponds with this uppermost point of the image, figure N. So now that we see these 2 points that correspond with each other, I just got to figure out how far this has been moved. So figure M, this point at the very top, I can see it's been moved to the right. And we'll figure out how far in a second. But then I'd have to go down to the right and then down to get from the pre-image point to the image point. Now that we have this, let's figure out how far it has been moved. So to the right, 1, 2, 3, 4, 5, 6, 7. I counted boxes, 7 boxes. From here, I'm going to count down how many boxes? 1, 2, 3, 4, 5, 6, 7. So to the right 7, and then down 7. If this is correct, each of the points should be moved to the right 7 and then down 7. So let's choose another one. I'll choose the bottommost point here in purple, which corresponds on figure N with this bottommost point at 1, -5. So what has happened here? Well, I can see it's been moved to the right again. And you could even count boxes if you wanted to at this point. 1, 2, 3, 4, 5, 6, 7 boxes. So it did move to the right 7. And then I can see it move down as well. How far? 1, 2, 3, 4, 5, 6, 7. 7 boxes. So it's the same movement for both of these points, which tells us that we should be good. We could continue to check, especially with only 4 points. Not too bad. So I'll go to the very rightmost point here on both figures. So from the pre-image to the image, I can see that I would go to the right. 1, 2, 3, 4, 5, 6, 7. So that checks off. And then I would go down 1, 2, 3, 4, 5, 6, 7. 7 units. So that one checks off. How about this middle point right here? This last one we have, which corresponds on figure N with this one. Well, how far it is to the right, and then how far, and this is down. Well, again, how many boxes? 1, 2, 3, 4, 5, 6, 7. So it did go to the right 7, and then down 1, 2, 3, 4, 5, 6, 7. So that checks off as well. This tells us that the figure has been moved correctly, and now we know that the translation has been moved to the right 7 units, and then it was moved down 7 units as well. This stuff really isn't too bad. Like, there's no calculating going on other than just counting on this. Can you count how far it's been moved? Or in which direction, right? We're not putting this into some kind of formula. There's no y equals mx plus b garbage. You just got to figure out how far it's been moved. That's it. Translating figures on graphs. So this is where we actually have to do the translations ourselves. So really all you got to do is follow the directions of the translation, left to right, then up and down for each point of the figure. That's it. But you do have to do it, and this is where it gets a little tedious, but it's for each of the points, okay? So this one right here, it says we're going to translate this figure, and they haven't labeled the points either, so that's fine. But we're going to take this 3 units to the left, and then we're going to go down 4 units. So we have to do this with all of the points, though, all of the corners, all the vertices of this triangle. So 3 units to the left, 4 units down. We should have enough space. So I'll start with this top point up here at the top. Okay, so I'm going to go 3 units left. So you could count boxes, 1, 2, 3. There's 3 to the left. And then it says 4 units down. So I could count boxes again, 1, 2, 3, 4. So if I go down 4 units there, then I end with this point. Now that's the very tip of the, I guess the top left tip of this triangle. But I'm going to have to do it with all of the points. So I'm going to go next to this bottom point, kind of the bottom left. And I'd have to go 3 units to the left. 1, 2, 3 units to the left. And then 4 units down. 1, 2, 3, 4. So this takes me down to this ordered pair. Then I will do the same thing with this point on the far right. I'm going to go 3 units to the left. 1, 2, 3. And then 4 units down. 1, 2, 3, 4. And that gives me my end point right there. Okay. So the last thing I need to do is just connect these points. So that is what I will do. I'll use some technology for this just because my drawings suck. So here's this one, and this one. So we can see this is a translation. We've taken this original triangle, we've moved the entire thing just by using the points. We've used moved the entire thing to the left 3 and then down 4. There's our new triangle right there. This one says to translate the figure 4 units left and 7 units up. So still a triangle, only 3 points to move. Hey, that's not too bad. So 4 units up, 4 units to the left and 7 units up. So I'll do the 4 units to the left in purple, just like we did on that last example, and then 7 units up in green. And like I said before, we're not really calculating anything here. All we're doing is counting, right? So let's start with this. Again, I like to start with the topmost point. I'm going to go 4 units to the left. Yeah, 1, 2, 3, 4. So that takes me this far. And then I got to go 7 units up from there. So 1, 2, 3, 4, 5, 6, 7. That'll take me this far. So this corresponding point on the image will be this new orange point. Okay, then I'll go to the bottommost point down here. But the process is the same, right? 1, 2, 3, 4 units to the left. So that takes me to the y-axis. And I'm going to go 7 units up. 1, 2, 3, 4, 5, 6, 7. That takes me to the ordered pair 0, -1. Then I'll do the same thing with this last point. So here on the very right, same thing. 4 units to the left. 1, 2, 3, 4. That takes me this far. And then 7 units up. 1, 2, 3, 4, 5, 6, 7. So that'll be, I'm going to do that line a little bit better. Maybe not. All right, there's my 3 points. All I got to do now is connect these with some lines. So, technology for me, because I suck at drawing lines. But if you feel good enough to do it, then do it. Okay, but this is the new figure. You can see it really is the same exact figure, it's just been moved. That's it. All right, we didn't really drag it, but that's pretty much what did happen. And there's our new figure right there. So 6 units to the right for each point, and then 2 units down, no problem. Okay, it's just, I guess it's kind of far to the right, but it doesn't really matter. So I'll start with the furthest right point here. And I'm going to take this 6 units to the right, and then 2 units down. So this ordered pair on the right, which is at, looks like -1, 9, I'm going to go 6 units to the right. So I count boxes, 1, 2, 3, 4, 5, 6. That's going to take me this far, to this street, if you will. And then I'd have to go 2 units down from there. So there's 2 boxes, 2 down. So this is my new ordered pair here in orange. But I have to do the same thing with this. I'll use this other top point right here. Now these are kind of going to overlap. That's okay, I can do it. I'll go 6 units to the right. 1, 2, 3, 4, 5, 6. So that's going to take me over here. And then 2 units down. 1, 2. There it is. And then this last point here in the bottom left, same thing. 6 units to the right. 1, 2, 3, 4, 5, 6. That's going to go 6 to the right, and then 2 units down. 1, 2. And that tells me where that last point will be. Okay, last thing I'm going to do here, just like I did on that last one, is connect these points. But I'll use some technology just because, well, it looks a little bit more pretty. There's that line, this one, and this one. Now, it's possible you may have noticed that the points are kind of the same. I guess you could say the same slope here and the same slope there. This one, same slope, same slope. Or even that these 2 points were at least 4 units away from each other, left and right. You could have did that instead of doing 6 to the right, 2 down. You could have just counted 1, 2, 3, 4, or 1, 2, 3, 4. It's the same thing. They have to be exactly the same distance apart.